Well, hi, good morning. Thanks so much for joining me in my shop here. I'm going to be going over the manual a little bit and showing you a few things that I've realized after all these years, and a couple other changes I've done in the radio I did late yesterday. Some minor stuff, and then I'm going to go on a big round, another round of resistance and voltage checks, because something I found in the manual that slapped my forehead. I didn't realize what was in this manual. I'm going to take advantage of it. So let me just talk a little bit about the challenge of working on this radio. So I'm kind of concluding that this is a very early version of this radio. And I think 60,000 of these were made, something like that. I'm not even sure the number, and my number here is about 2,500. A few things I've noticed that have confused me about the actual date. The main thing being the fuse in the back here, where this fuse was a spare, but in this radio the fuse has been used to protect the primary winding in the transformer. I did that. I did that. That's my change. This was a spare, and I turned it into a useful fuse, because in the manual here it showed the fuse. It showed a fuse in that circuit, so I took opportunity to do that. I took out another string of resistors. I think I threw it in the garbage already, and I replaced it with a single resistor, and that's way back in here. Okay, that parts list tells me that that's a 2500 ohm 10 watt resistor. It certainly looks like a 10 watt resistor. Did I replace it? Is that something I did? Not like I have, back then I had any kind of parts, to do stuff. When I was in college, I just had a few little bits and pieces here. 2500, okay. In circuit test. Well, that's 2500 all right. Well, good. Okay. That's the end of that story. I think what I will do next now is I'll begin taking the resistance readings on every one of these terminals and compare it to what is expected. And that should track down a few more bad parts. I'm pretty sure that's what that's going to end up doing. So maybe even a little bit of my bad work might show up in there too. Great. If I'm going to do that, of course, I'll do that off camera because it's pretty tedious stuff. Right, so I'm starting what must be 50-60 measurements. The very first measurement, I've turned the camera on because there's something really weird in this radio. And again, it's probably my doing from years ago. Let's take a close look at it because I'm not sure what I'm seeing even. Hopefully this is focused appropriately. So we're looking at this pin here. So what is weird about it? Is this little nubbin of wire here? Right, it's hard to see in the camera right here. There, now you can see there's a piece of wire going across from here, and hard to see. It's not soldered. I mean, it's almost certain that I did that. What was I thinking? Why would I do that? Yeah, you can see it clearly. It just kind of got bent around. Is it just possible I couldn't see well enough? I thought that was one terminal and I did that? Surely to goodness this is a problem. I mean, you can't, that's not supposed to be there. Because if we look at the diagram here for it, that pin number 8 is actually just out there doing nothing. Now again, every time we look at these diagrams, you gotta wonder, is this really the way the radio I have is supposed to be? So here's the area that I'm looking at. Here's the pin, the last pin. It shows nothing hooked up to it. And you see pin 7 with, oh my gosh, 1, 2, 3, 4, 5, 6 things connected to it. So when I count in my radio, there are not 6 things on pin 7. Some of the things on pin 7 have been moved to pin 8, and a jumper has been put in between. So I think that's all that's going on here. Probably a later revision in the radio. Probably the radio builders themselves said, why are we doing this when we got a spare right here? Why don't we make use of it? Probably something like that went on. So I'm going to solder that connection in solid, and the measurement then for 7 applies to 8 too. It's the same pin. Spread pin. That's the story there. I knew what I was doing back then, I guess. Surprising. Surprising this radio's been working with stuff like this in it. I checked very carefully. It's not soldered. Fairly easy to see too, so I think I just forgot about it. Okay, that's gonna do it. Yes, quite a few side stories going on with this radio while I'm working on it. Here's a quick side story. The radio is really supposed to have a 5R4 in it, but this radio has a 5U4. Same kind of tube, except the 5U4 draws an extra amp of heater current. That's quite a bit. So 5R4s, I don't have any. Oh, wait a minute. I looked really hard. I got 2 of them. 2 5R4s. Both dead. Too bad. Side story. Let's try it again. I saw 674 go flying by. Well, I'll be 660. Oh, hands in the way. 660. So it does match. So it matches right here. 680, 660. Sounds like the same thing to me. Good. Okay, no problem there. So now we're back to this one. So we try to figure out what is going on here that would give all these readings. It would be easier to look at the schematic diagram and pick off these components and then study them. But wow, it's a little hard to get from here to the schematic easily. I don't think there's an error in the wiring here or anything. I think it's one resistor has gone high. So the values of the resistors are not written in here. What do they have in common? Let's see. So this one's gone high. You see, there's a wire that runs from 13 all the way down to here. I'm getting this high reading here. So getting the high reading over here, but it's basically on this reading is the very same. No, it's the other side of this resistor. Well, I guess I can just make like a basic check of the resistances of these resistors in circuit, and I mean it's got to be like a 1 meg resistor that's gone high. Maybe I can find something like that. I'll find one that's marked 1 meg but reads 2. That might be the deal. Okay, I'm going to get busy on that. So I have pursued all the resistors that might explain the resistance measurement that doesn't quite add up in this part of the radio. Every resistor I check is right on the money. So I can't find any reason for this one reading to be different. But now I'm on to another reading. This is the yeah, I'm confused myself because I was out of the shop. This is the same reading. This is the 2 meg that I read when I should be reading 1 meg. So you can see 2 on the meter. And I'm just hooked up to the 3rd terminal on the strip here. There's a number of places where I can get this incorrect reading. I think what I want to do now is demonstrate what happens when you flip the AVC switch from ABC to manual. I'm back to ABC. Okay, so this is the first kind of hint as to where in the circuit this even occurs. ABC, And so this test is supposed to be done with the AVC switched on, and that's how it is now. So supposedly, you know what, audio gain at max. I'm going to move a bunch of other controls here and just see if I can make that. Here's the band change. Going from below to above. Didn't seem to do anything. That's changing the bandwidth. It's not doing anything. That's the audio RF meter switch. If that did something, I would be freaked out. This shouldn't do anything. Just nothing. The only one is this guy here. Makes a big difference. Well, I think I'm going to trace away on this for a while and see if I can find, you know, again, I'm suspicious that there's like a megohm resistor that's doubled in value somewhere in here. But with the AVC hint, that might help me trace this a little better. So, wish me luck. Off I go. So I think I found where the 2 megohms comes from. If we follow, and this is a little tricky to do, we follow this line right here from the AVC switch. Follow this wire. It's long, it's very hard to do. Goes up here. It reaches R60 and R61 and goes to ground. These are both 1 meg resistors. Voila. Now, if this is what I'm reading, but it's not supposed to be this, it's supposed to be half of this, how does that occur? There's no more resistors or circuitry going further. Must be something happening back here. So here we have a crammed in here switch. I threw this switch, it made no difference on the reading. In fact, I can do it right now while we're talking here. I'll just flip that like that, flip that like that, like that, flip that like that. Wait a moment for the reading to come up. Flip that like that. So switching this switch has no effect. So it's hard to see, since it breaks the wire here, how it could be a problem up this way. So we'll come back along here. Now there's a resistor from here. This is a really big thing. This is a 3.3 megohm resistor here. That doesn't help you get to where you want to go. That's it. From here, I mean, you got to go through this gigantic resistor. So this is starting to look like a wiring error, and it could be because I replaced one of these switches. When I got the set, one of the switches had already been replaced, and the replaced switch failed, so I replaced it again. Which one was it? You know what? All these switches look replaced when I look at them. They all look weird. I don't know what to think. I'm going to have to carefully trace this part of the circuit. You know, here's the RF gain control. It works. These are not, but in AVC, these are not switched in except through this guy. You know, maybe I've miswired the switch somehow. So yeah, so I have to study this. So I've been studying the schematic here for a while now, trying to understand how a line with 2 meg resistors in series at the end of it is supposed to be 1 meg, and I can't find any explanation as I search through the schematic here. It would seem to me 2 meg is correct, and the 1 meg I'm trying to hunt down doesn't exist. Maybe that's from a different version of the radio or something like that. And in the back of my mind, deep in the recesses, I am welling up memories of having already done this some years ago, this exact same journey. So I'm going to leave it at that. The radio does seem to operate fine. These resistors are there, it's all there, so whatever I think is a problem, I don't think is a problem. And that's about all I can say about that. Okay, so I think I'm all the way through all these resistance tests, and in the end I don't think I made a single change to anything. Everything was explainable. Really not too much here that's far out, except for the 2 meg 1 meg thing, which I now conclude really should be 2 megs as it is. So now there is something I want to take a peek at in here, and that's this resistor, which I'm pretty sure I put in, and knowing me, I better double check all this. So I'm going to figure out what that is and what value it should be. Okay, so that is a cathode resistor on the 6V6 output tube. So the fact that I changed it, not too surprising, but let's just see if we can find it on the schematic. Should be quite easy, really. Just need the output tube. Where are you? Here we are, output tube. There it is. R99, and it's supposed to be bypassed by C151. Well, that's interesting. C151 and R99. Can we find R99? R99 here. It's an odd resistor. There shouldn't be a bunch of them. It should be low, like far down the list here. Why isn't it? Oh, it's over here for crying out loud. There we are. 360 ohms, 1 watt. So a 360 ohm. That's pretty typical for a cathode resistor. Now, it's supposed to be bypassed by. Let's go back here. Okay, so it's bypassed by C151. Okay, so how big is C151? There it is, 151. 100 volts. So is it really 360? Let's measure it. That's probably the best way to find out what it is rather than trying to read what it says. 150. Holy smokes, man. What a disagreeable thing. $330. Instead of 360, wasn't it 360? 360. That should probably be, I should probably change this. Because it's going to cause the tube to run a little harder than it needs to with a slightly lower resistor there. And then where's the bypass capacitor for that guy? It's a 10. All the 10s look like this, I think. There's one here. But it's kind of far away. Oh, didn't I? Oh, I concluded it was this. He says. Well, you can practically see the green wire heading right up there. Practically, I can see it. So yeah, this is the bypass. So this is the bypass now. So it's all done except maybe I should put a 360 here. 360, right? Okay, I'm going to think about that. Okay, so the next thing I'm going to do is repeat all that, only doing voltage tests with the set operating, and collect all that information, get it on the page, and see if that leads to anything interesting. Okay, let's just run through the instructions here before I start. So where you turn it on and start doing voltage measurements. So no signal input, RF gain off to measure resistance, all measurements made to the chassis. RF gain at minimum, normally you have to turn it on, you have to turn the radio on to get it on, so it's the RF gain control that has the on-off switch on it. So you turn it on but leave it at minimum. BFO injection, that's on the back here, and I've already turned it up full. Audio full. AVC manual switch at AVC, and that's right here. That's done. Limiter it off. Yeah, the limiter's off on this. We almost never use that feature. Use VTVM for negative volts. Use volt-o-meter on 500 volt scale to prevent circuit loading. Use 10 volt scale to 10 volts. I'm not sure what that last part means. Not marked indicates not measured. Not NM means not measured. So what they're warning about here is you better use a high impedance voltmeter for making the grid measurements, the negative measurements. It's a very high impedance circuit, so my VTVM is fine. Use a volt-o-meter on the 500 volt scale. So again, they're trying to tell you to use your equipment in such a way it won't load down the radio during the test. That's really important because sometimes the information in service manuals is based on loading the circuits with a lousy meter. They declare that in there somewhere. These measurements were made with a lousy meter, except they don't say lousy. Right, they give the ohms per volt reading. Enough of that. I'm going to use the my VTVM here. I got a little ahead of the game there. Let's get it operating. So I check. Okay, so the volume's up a little bit on our. I'm going to turn this down because first thing I want to do is just. So it's not driving into a speaker. It was supposed to be no signal input at all. Get that off there. Okay, no signal input. So that shouldn't cause much of an output. Just a hiss going to come out of the radio. I guess we can turn the volume right up full. Okay, so the set is switched on, but the power's not on to it yet. And I have my headphones on. I'm going to run it through the two dim bulbs to start with because I did make a number of changes in here. Last night I was changing some resistors here. So if you're looking for smoke, this is the area to look for the smoke. Okay, can't see any reason to hesitate any further. Let's come a little bit this way. You can watch the light bulbs light up. Good. Now, those clearly did not come on to full brightness and they're going down already. So that's a good sign. Everything's good. Radio's good. Did I turn this down? Blow our ears off. Not exactly sure what we're going to hear. Okay, so I'm going to raise up the voltage here. It's only at 80. Here comes the radio. There we go. Hey, what's happening? Hey, this is a really bad sign. What about that smoke thing? Oh, it's not bad. I had this on CW. So, yeah. It's not a bad sign. It's kind of a bad sign. It shouldn't be making that sound all the time. Yeah, that was a little unfortunate. But, okay, we'll get to that eventually. So we don't have an antenna, so we can't really know for sure. But, so I'm on the double conversion, one of the double conversion bands here. Turn that down. I got my phone in my pocket again. Away from here. So I'm going to cut the sound out because the radio's working. We don't need to hear it. So I have to turn this up all the way. You can just imagine how much signal there is. I'm going to take this right off the back too. So I'm very uncomfortable turning it up full like that. Annoying. If I hooked the speaker up, it'd be screaming right now. But Do as I'm told according to the instructions. Now we're ready to start the testing. We're ready to start testing. Graph this here. First thing I want to do is look at the voltages on the power supply capacitors and see that they haven't gone crazy or something is at risk here. 500 volt scale on the meter. Here we go. Okay, so this one is 240. That's low. 220. It's gone down. Well, that might be a good thing. 220. I was getting 300 volts in here before. What have I done? That's on. Oh, I know what it is. I don't have full line voltage here. Okay, so this poor guy, 100 volts. Let's take him up to the 117. Okay, 117. I could hear a hum come up in the radio itself as I did that. Some transformer humming. Okay, now we're where we were. 310, 260. Watch it, man. Watch it. Okay, radio's working. We're ready now to do the test. I will do the first terminal and then I will stop the video and carry on doing the rest of it. First terminal is second terminal in on the top strip. Remember, Jim, there's voltage here now. Voltage reading is 205 volts. So on the 5 volt scale, 205 volts, going to be up about here. And this is on this one here. So it's way above 205 volts. 265 is what it says. It doesn't say 205. 265. Oh, I can't turn my head. It's like 275. There we go. 260, 70, 275. 275 instead of 265. That's hardly a problem. Okay, so I'm going to carry on through the rest. I don't expect to find anything out of the sorts because the resistances were all good, the radio works. I'm not expecting anything. And the reason, and because I'm not expecting anything, something's going to happen. Okay, so I've completed the voltage testing. It's really extremely difficult and nerve-wracking doing that because you have to stick your test probe into there, and I don't for the life of me steady my hand on the chassis or anything. I try my best. No, I absolutely will not touch anything when I'm sticking the probe in there. That means my arm is kind of free like this. It's really scary pushing stuff. And then you gotta, if you do this work, you know these things. You get it in there, now you gotta look away at the meter, and while you're looking away at the meter, who knows what happens to the probe. So it's very challenging doing this, but it has revealed something. Everywhere you're supposed to find minus 10 volts in here, there's 4 or 5 places, every one of them came out at minus a volt. Why that is exactly, I don't know, but that is something we're chasing. Everything else is okay. Everything else came out, you know, relatively okay, but not the minus 10 volts. So we're going to have to investigate that, and just looking at something here. Okay, yeah, we're going to investigate that after lunch for me. Okay, no lunch yet. I have to defrost our homemade turkey soup. Wow, so I'm back in here again. The 10 volts is derived here in this voltage divider, just 2 resistors, from the 51 volts that is created up in this part of the supply from here. These resistors are all 10K. I have checked them. These capacitors I have replaced. These are the ones that are over here on the side of the radio. Here, instead of ever getting minus 51, I'm always getting minus 75. That's quite a bit higher. Why that is exactly, I don't know. Just going back here. So the plates of this rectifier tube are hooked up the same as the plates of the high voltage one, right onto the output of the high voltage secondary here. These resistors, this one I measured, it's exactly what it should be, 82. This is a chain resistor I had stuck in there, was 96 ohms. I replaced it, it's now got 82 ohms, so this has changed. I was thinking having these out of balance might have caused some kind of hum through here. I don't know for sure. This is really critical that this be quiet, because this is what's going to be powering a lot of the grids in here in the radio. So you don't want any hum at all in this. Why it's minus 75, I still don't know. So what could be wrong here? This minus 10 should be minus 11 or 12 because this is high. But it's not. It's only minus 1 here, or even barely that. So the only thing I can think of that can possibly be wrong is these two resistors. Something's wrong with these two resistors. I got to find them. 95 and 96. And I know from experience, well, actually from experience, what it says in this manual that I got with the radio is pretty much correct all the time. All the other information I find on the internet, there's variations in this kind of stuff. So let me rely on this, 82 and 22. And now, somewhere in this radio are these resistors. So I am going to go and find them. Okay, I found them. They are the two resistors right here. This one here, and then there's another one. You just barely see it, kind of going downwards here. This second one going downwards goes down to a grounded terminal, and here they're tied together here, and it starts here. So you can go on this terminal, 71 volts there. Here should be 10, only 1. How come? So first I'll try measuring the resistances here first of all. 82 and 96. It's almost the same, isn't it? I mean, it's almost really just almost the same. Almost the same. Split the voltage in half, but it's coming all the way down to 10 from 50. In fact, it's coming down to 1 from 75. Those two resistors have current being drawn out of them on a line. Could be that that might be the problem. What I'm talking about here is that there's just not two resistors sitting there. It's a voltage divider for a purpose. So there's this wire disappearing here. All kinds of stuff hooked up to it. The current draw on this wire isn't correct, then the voltage drop in this resistor won't be correct. So what would happen? So let's say there's no current draw here, and there should be. So that would reduce the current draw right out of here. It would reduce the drop on these. These would all start going higher than they should be. Maybe you get 75. Maybe that's the whole problem. Now, on the other hand, if you don't draw current here, you have less current here, so you have less drop here. You have more drop here, so you end up with a bigger voltage. Now what if you do the opposite? Like, what if there's a short out on this line somewhere, not a dead short, but a near dead short? And you're going to draw a lot more current through here. That's going to reduce the 51 though. 51's high, assuming this is all related. All these things are all related. Can't quite think my way through it. Let's measure those two resistors. Once in a while I've done stuff like that and actually picked on a particular component and said, that's got to be the guy, and I've been right. Okay. So we're expecting how much resistance here? We need that to be like that. Now, testing these in circuit. trying to test these. You know what I'm going to do? To get a better reading here in this situation, it's better to use clip leads. So we're on 80 on that one. That's probably the 82. Yeah, it is the 82. So 80. So now the other one goes to ground. So all I got to do is just move this and then pick off a ground somewhere. A nice little ground. Here's one. It's supposed to be 22. Look at that. It's coming up right at it. So the only reasonable theory. Well, there's another possibility here too, in that. So, yeah, but you know, like I was gonna say, maybe this isn't drawing enough current down through here. Fat chance on that, and that's why this is high. I don't think this is the case. But then this would go high. It's not going high. It's going low. It's going low. Low, 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 low. Something out on that line, and that line probably goes all over the place. Holy smokes! How are we gonna figure that out? Now didn't I take? Yeah. Okay, gotta stop and think about it. I gotta stop and look at the schematic really and follow that line all over the place.